Hey, it's Mr. Farrell here. So in today's video, I'm going to cover impulse. All right. Impulse is important because it helps us understand how a collision affects an object, how a change in velocity affects an object. So we actually end up having two different equations for impulse. All right. So the first equation helps us see how a change in velocity affects impulse. The second equation helps us see how impulse affects the force that an object feels. Okay. Now we're going to go over what the different variables mean, and then we're going to do some algebra work just to make sure we understand how to algebraically solve these equations. Okay. So delta P is impulse, right? Impulse is delta, which means the change in, P, momentum. Okay, so if you call P is momentum, right? So delta P is the change in momentum, or what we call impulse for short. M is mass, and delta V, again, we see the delta, which means the change in, and V is velocity. So delta V is the change in velocity. So we can see here, the change in momentum is mass times the change in velocity. Okay, so very close to the momentum equation. All right, now over here in the other impulse equation, we have force equals delta P over delta T. So F is equal to force, delta P is equal to impulse, again, change in momentum, and delta T is the time duration of a collision. Okay, now to talk a little bit about how these equations work, we normally use them with each other, okay? So they both give us a little bit different information. So this impulse equation helps us see how impulse and velocity are related. So if you have a larger impulse, you're going to have a larger velocity. If you have a smaller impulse, right, a smaller change in your momentum, you're going to have a smaller change in your velocity, okay? So the larger the impulse, the more the change in velocity. The smaller the impulse, the smaller the change in velocity. Now, that helps us a lot, right? Because we can understand how much our momentum is changing, right? Now, this equation helps us understand, right? If we have our momentum changing, right? We have an impulse. How does that affect the force that an object feels? Okay. For example, if a vehicle gets into a car crash, it will experience an impulse. But based on this equation, it'll let us know how much force that collision has, right? So you can have two equations with the same amount of impulse, but depending on the duration of the car crash, the time, the change in time, that'll actually determine if the force involved in the collision is very harmful and deadly, or if it's not harmful and deadly. Okay. So normally you'll use both of these equations together. So for example, you may be looking for the change in velocity, but you are given the time and the force. So you would use this equation to find the impulse, then plug the impulse in over here to find the change in velocity. And then it also happens vice versa. For example, one of the things we're doing in my physics class right now is we are looking at changes in momentum using the conservation of momentum equation. So we are going to calculate the change in velocity on an object, right? And use that to calculate the impulse. And then we're going to plug the impulse in over here to find the force and see how deadly that collision was. Okay. All right, so there's a lot of work, a lot of things that connect these two equations together. What we're going to do now is solve them algebraically, just so that we are comfortable working with these equations. All right. So first equation we're going to work with is delta P equals M times delta V. All right. So currently this equation is already set up to solve for impulse, or the change in momentum. So if that's what you're looking for, you don't have to do anything to this equation actually. All right. Now let's try to solve for mass. Okay, so let's say we know the object's change in velocity, we know the impulse, but we don't know the mass of the object. Well, right, currently the mass is being multiplied by the change in velocity, right? Remember, this delta and the v are the same thing. So if it helps, you can put parentheses around it. These are not two different things. They're both one variable, okay? So currently the mass is being multiplied by delta v. So what we need to do to separate multiplication is do the opposite. So we're going to divide on both sides. All right, and we're going to divide by delta v so that we can isolate m, right? We are trying to get m by itself. So we're going to divide by delta v on both sides, and we can cancel it out. And now we're left with delta p, the impulse, divided by delta v, the change in velocity, is equal to the mass of the object. Okay? So very simple 3-variable equation, just solving for mass. Okay? Now, let's say we know the mass, but we don't know the change in velocity. Well, we're going to actually do the exact opposite of, well, not the exact opposite. Instead of dividing by the change in velocity, we're going to divide by mass. Now, again, that's because we're trying to isolate the change in velocity in this third scenario. So we're just going to divide by the mass on both sides, and that should leave us with the change in velocity by itself. All right, so we end up with delta p divided by m is equal to delta v. Now, again, you would use this if you know the impulse from the collision and you know the mass of the object that was involved in the collision, but you're still trying to figure out, okay, so how much did its speed change, right, after the collision? And this will help you figure that out. Okay, great. So that is enough with this equation. And we're going to go ahead and move on to the other equation. And again, this tutorial is really just explaining the variables in the equation and showing how to algebraically solve it. Okay. If you want to do practice problems, that'll be a different video. All right. So here we've got force equals delta P divided by delta T. If we are solving the equation for the force, right, the force that the object feels from the collision, then this is already set up how we want it to be set up because we are currently solving for force here. All right. Now let's say we wanted to solve for the impulse. All right. So we know the force, we know the time of the collision, how long the objects stay in contact as they collide. So we know that. We're just looking for delta P. So we're going to do the opposite here of what operation is currently happening. So currently division is happening, so we're going to multiply, all right? And we've got to multiply by delta T, all right? Because currently we have delta T in the denominator, so we're going to multiply by a delta T in the numerator, all right? So multiply both sides by delta T. That'll cancel out the numerator delta T with the denominator delta T. And I'm left with delta T times F equals change in momentum delta P. All right. Now, again, once we solve for this delta P, we could then use it in this equation to solve for the change in velocity. It would normally work that way. All right. But in this case, we solve for delta P. Let's go ahead and do another scenario where we have to solve for the time. Okay, so I'm going to go ahead and erase all this. Draw my time back here. All right. So if we are trying to solve for time in this equation, we need to isolate delta T. Now the issue is if we go ahead and try to isolate delta T right now, it's not going to work because delta T is in the denominator. We want to isolate delta T when it's in the numerator. So let's go ahead and multiply both sides by delta T, right? Because this is multiplying by a delta T that is in the numerator. So these delta T's cancel out because one is in the numerator, one's in the denominator. So they cancel out. But this delta T gets to stay. because it is in fact in the numerator now. Okay, great. So we're still trying to solve for delta t. We have it in the numerator now. All we have to do is get this f away from it. So currently multiplication is happening between f and delta t. So we're going to do the opposite of multiplication, which is division. And we're going to divide by force, f, on both sides. All right. So that's going to cross out both of the f's, one in the numerator, one in the denominator. And that leaves us with delta t is equal to delta p divided by f. All right. So you would use this if you just found the impulse from this equation and you already knew the force. You could use this equation to find how long were the objects actually colliding. Okay, cool. So hopefully this has been helpful. Again, we just wanted to go through how to algebraically solve this problem. So you have something to use and a tool to help you while working through impulse problems. All right. So thanks for joining and have a great day.